Hello, today we're going to be looking at the exam video module 2, and we're going to be responding to prompt number 2, which is on genetic linkage. Now, our subject today is going to be flat-coated retrievers. Now, this species has 78 chromosomes, and which is 38 pairs plus 2 sex chromosomes. And there are going to be 3 traits that we're going to analyze today. So the first one is hair length, which can be long and short, the affinity for tennis balls, which can be high and medium, and the running speed of the individual, which is going to be fast and slow, with the dominant and the recessive allele listed respectively. So these traits are going to be autosomal recessive, and the calculated coefficient of coincidence is going to be 0.7326. So let's say we have two parents. One of them is going to have long fur with a medium affinity for tennis balls and is slow, while the other parent has short fur, a high affinity for tennis balls, and is fast. Now these two individuals are pure breeding from a long line of their respective traits and are going to be homozygous for each trait. They're going to produce a completely heterozygous F1 offspring generation, which is going to look like this below. Now what would that look like more visually? So we're going to have parent 1 with long fur, a medium affinity, and is slow, and parent 2 that is short-furred, a high affinity, and is very fast. And their genotype is listed below. Now the heterozygous individuals in the F1 generation are going to look like this, and are going to be heterozygous for each trait, with parent 1's genes that were passed down on top, and parent 2's genes that are passed down, or alleles that are passed down on the bottom. So if we take the F1 generation and we breed it with a completely homozygous, recessive, pure breeding individual, we are going to get this spread of probabilities. Now the various probabilities that can occur are no crossover events, one specific crossover event on either side only, and then a double crossover event where two of the traits on either side cross over. Now if we look at a single crossover event, let's say we have a crossover at hair length. We're going to take the centimorgans, we're going to divide it by 100 to get the probability, which is 0.13, about an estimate. And we're going to subtract the ability of a double crossover event from occurring. And then we're going to divide that by 2, because that can occur in 2 different ways. So we're going to reduce it to only 1/2 of those instances to get 0.055 for a single crossover event at locus 1. And then for a DCO, we're going to have both events occur times the coefficient of coincidence divided by 1/2 for the same reason to get 0.01. And of course, here are my citations.